Well, hello out there. I wanted to give a little update on my new Goliath setup with the VZ extruder. Currently I got the air-cooled version, and apparently there's supposed to be an adapter that goes in here to mount to this so you can take out a bolt on each side to remove this, but I really didn't want to do that. In fact, I didn't really know about it when I bought it, but I had planned on mounting this sink right to this top plate so I can dissipate the heat through this whole top aluminum piece here. And I didn't want to go water cooled because I'm a little scared. I didn't want to have a water leak and some sort of issue down the road. And so I went with the air cooled version, and I'm using a bird air here. Here's the little line for it. And I've basically taken a part of the bird tubing, the nozzle one that has the holes in it, and I cut it into a half circle here, and the holes are on the back side of it, and I just wedged in between this these fins here, and so this runs up to the top here, and that's how I'm cooling it. It seems to work great. Also on this tool head, this tool head is actually about 70 grams lighter than this setup here. So this is a Volcano Mosquito, and even though the Goliath looks taller, it's actually quite a bit lighter. I really like this setup, but I've got the spacer inside here, and it can be real pain to get that spacer out of there. I've actually had it lock up in there twice on me, and I had to drill it out, use the easy out, get it out, clean it. It was a nightmare. So, and this flows somewhere around 42. You can push it to about 48 with some temperature. So far this one here will do 50, 60 no problem with the CHT. With a 0.4 nozzle, I'm not quite sure. I'm not going to say right now. I did do some testing with it, and I could see some issues with a 0.4 around 45, but I haven't used it enough to really be sure that it wasn't me. It could be me, you know, but right now with the CHT I printed 50, 60, and it's a humming. So with this setup here, it may be kind of hard to see. I've got these three plates, two plates on the bottom and one plate on the top, and there's a bolt here that joins these two bottom plates together, and it pivots from that point. And so these holes are slightly slotted, just a little bit, so you can loosen up this bolt and these four bolts on the top, and you can twist this ever so slightly to get this thing square. It's pretty handy. So if your stops in the corners are square, you can butt that up to the corners and then just tighten down this bolt down here on the side and then the four on top, and boom, it's square. But if you don't have something squared up to begin with, you're gonna have to go through some other methods to get that. And even here on my back mount, let's see here, I've got a jack bolt right here, and so I use those jack bolts to get it so that it's square, so when it bumps it's going to be square. So mostly everything here is aluminum except for the duct, and this duct is a little bit different. It's almost the same, it's just narrower. See, it's a little bit narrower than the old duct. Okay, and I printed a Benchy in 6 minutes, and it actually came up better than some of the other ones, and I couldn't tell you if that's from the cooling or from the hot end or what exactly it's from. I don't really know. So I'm having some tuning issues, but all in all it's printing good. I printed this rose. It's kind of hard to see that. I printed this rose here in 4.5 minutes, and I think it came out better than my previous prints of this rose. So of course I could jack the speed up on it because I got more flow now. So before I had to have a lower layer height. I think that was 0.3 layer height. I think around 30,000 acceleration at 500 millimeters a second. It printed about 4.5. It printed pretty decent. So I attribute that to the hot end. Even though I saved 70 grams, my 80XL tests are about the same. They really didn't change, you know, much of anything. I don't know why. Maybe the other setup was, the CG was a little better. I really don't know. So, and of course, now another issue that I can see that could be better. Let me get a piece of a little shim here, and I can show you what's going on here. So if you push on this here, I don't know if you can see that, but that's moving up and down right here in the back. And that motor is not touching this plate. It was designed, I guess, so that it has a little bit of a gap there. I would have preferred this to be right on that plate. I can take a piece of filament here, and it just slides right underneath there. I don't really like that. I don't want it to bounce or to find some resonant frequency and, you know, match the frequency of this and start to bounce. So I'm going to have to make something to go underneath there. What I might do is just thread a hole in the top, put a panhead bolt in there, and then turn it to put pressure on the back end of this, so this thing doesn't have the ability to bounce. It's probably hard to see that, but it's definitely moving. It takes a little bit of force to do it. It's just not my preference. So, and then the next stage we're going to do here is we're going to change out these blocks to all aluminum. I don't know if that's going to save any weight, but it might clean this up to be a hollow frame. It might be a little bit lighter. We'll have to see. Also, I have a fan down here, right here. That's a 120 millimeter blower fan, and this used to be my layer cooling fan, and I didn't find much use for it. It didn't seem to work that well for me. He had a duct on it, blowing on there. But what I find useful for that is if you're printing something like PLA, my CPAP entry is here, and my 120 blower is right there. So you turn that 120 millimeter blower fan on, and it takes that. If you have the front open, you're printing PLA, you crank that thing up, and it sucks that colder air and blows it right up to that CPAP entrance, and then it just goes into your duct. It'll give you a little bit better cooling. And of course, I have the all metal mounts. These are the Speedy Power 2504 motors, and the only way that I can get these motors to give me 70,000 acceleration is to crank the amperage up to about 2.1. Then I can get 500 millimeters a second at 70,000 acceleration at 70 jerk, or I'm sorry, 70 square corner. These are moving quite a bit of weight. This is about with the carriages blocks on here, this assembly weighs about 380 grams. It's a chunk of weight. When you put that in your hand and hold it, my gosh, that's a lot. It feels like a lot. So when this thing is zipping around, these motors, I have a hard time moving that, much more than that acceleration at that speed. You can slow down to 300, millimeters a second, and you can go, I'm sure, close to 100,000, maybe a little bit more. But you're not going to print any faster by lowering the millimeters per second and increasing the acceleration. They're going to even out, and it's going to be harder on the machine, I think, with the higher acceleration. At least it was. I tried it, and it seemed like the printer was more violent with the higher acceleration in the lower speed than it was with the higher speed and the lower acceleration. So, well, anyway, that's the printer here. Just wanted to kind of show you what I've done. Thanks for watching.